So I didn't do a good job of preparing for this talk. I apologize. All the links that I'm gonna like wander around aimlessly through are on this bit.ly, which is bit.ly 32927Y0. So I would have gotten a nicer one, but that's what we've got so far. So I'm going to talk about, what am I going to talk about? I've got so many different things. Let's not lose everything here. Okay. Thank you. Yeah, it's 32927Y0. All right, so I'm going to talk about the semantic web for a second. Who here knows anything about the semantic web? Raise your hand. All right, we got take it a little higher. Show yourselves. Okay, cool. So, I mean, in a nutshell, the semantic web is about expressing information in a way that machines can understand it. So I think this term may be coined by Tim Berners-Lee, and part of the vision behind the semantic web is these like linked data formats. And linked data is a way of expressing information in a way that machines can understand it and make use of it. And so part of the vision behind linked data is turning the internet into a giant queryable database. So if you've used Wikipedia, you've experienced linked data before, because Wikipedia is like generally pretty good about constructing information in a way that makes it available to machines. When you go to google.com and you search for Chuck Norris, and you notice that in the right-hand side of the screen, there's like related movies and like, all these concepts that are related to this guy and actor. Like, how does Google know that movies have actors and actors read scripts and movies have scripts, and what the relations between these things, like they have to be expressed in some structure. So linked data formats are a way of expressing that structure. And what I'm going to talk to you guys about today is a specific format of linked data called JSON linked data, or JSON-LD. So JSON-LD, it looks like normal JSON. Let me get to my thing. So this thing on the right-hand side of the screen here, can everyone see that? Hopefully better now. So this thing on the left-hand side of the screen is JSON linked data. And the main point that I want to draw your attention to is this little context block here. So what this does is actually it defines these terms in a semantically unambiguous manner. So when you go to this URL, you can see that a thing called a verifiable credential has, oh yeah, plus like a ton, yeah, thank you. I'm gonna need continuous reminders about that. So you can see there's this definition for like what is a verifiable credential, and there's some pointers to things like XML. You're like, oh, I don't want to think about XML, but you might have to think about XML at some point in your life, especially if you work with the government. So the point I want to make here is that these little prefix things here, like cred evidence and cred credential subject, they align with this concept of cred up here, which is defining a vocabulary. It's defining a namespace. And then what that does is it lets everyone who sees credential subject know that they're actually talking about this kind of credential subject. Oh, well, of course, the W3 has broken resources. This is my life. I deal with fixing these issues in identity and security space. So I didn't give you an intro of me. I'm Orie Steele. I'm CTO and co-founder of Transmute, and we help build identity and credential software on top of blockchain, decentralized identifiers, and verifiable credentials, which causes me to spend a lot of time with JSON linked data. So all of this is all just intro to try and sort of set the stage for what is this data format and what's usable, like what's useful about it, like why does it matter? And the bottom line is that if you want to have interoperability and you have a term like credential status, what does credential status mean in one JSON object and in another? How do you know that that's the same credential status?
So it specifies how to use that piece of information, but does it say what's required to be a credential or credential status?
Yeah, so in a way, this context thing that we're looking at here kind of defines the semantic information about the object, but like it's not really a type system. So like, who here is familiar with JSON schema? More people, hopefully. More people, okay. Yeah, like so JSON schema like helps you define types. JavaScript is a terrible language without types. Sure. Oh yeah, oh yeah. Oh, I went there. So here's the thing. Like, so yeah. You can fight me after the talk, but when it comes to standards, defining the type of things, you have interfaces. There's all of these tricks that we use in JavaScript or in TypeScript or whatever to try and make it as easy as possible to tell what is the type of this thing. And that's not really what JSON-linked data is here to help you with. JSON schema can help you with that problem. JSON-linked data is here to tell you that a credential schema is a URL that points to some concept of the structure of a credential. So a credential schema URL might be a pointer to JSON schema, but the concept of a property called credential schema, it has a semantic meaning that a machine can parse if it's described in JSON-linked data. So before I take you further down the rabbit hole, if you have questions or you're looking at me with concern, I'm sorry I said the thing about types. Okay.
Quick question. Is this like a 33 standard?
Oh, yeah. So I got like halfway through my intro. Yeah, so the JSON-linked data is a W3C standard. And I work with the W3C with a large number of companies on a number of issues. And the Decentralized Identifier standard is an emerging standard in the W3C. The Verifiable Credentials Data Model is another emerging standard in the W3C. And both of them make heavy use of JSON-linked data. JSON-linked data is also used in Solid and like ActivityPub, which is related to Mastodon. So these things they're all related. Cool. So now that we've sort of like shown you what these terrible context objects look like, let me just sort of back up for a second and talk a bit about schema.org. So when you have a website and you want to express the concept of you're selling your car on your website, you can use schema.org to make the concept that you have a car, specific make and model, that you're offering to sell that car for a specific dollar amount, that you have a name, that your car has a VIN number, like all of that structured data can be expressed using JSON schema. And using JSON-LD, sorry. If you express data on your website, like 15% of the websites on the internet use JSON-LD today, and maybe that number might not be totally accurate, but a good number of them do, then when Google crawls that, it's going to add that to the knowledge graph. It's going to be aware. This website here is actually selling this car here related to this make and model. And so when you start to ask the question of what are the current cars for sale that are made between this date range that were hosted on websites in these countries by people who had these Twitter handles, you start to like make this really tough joined thing. You start having to like crawl this linked data structure. And you can actually do that if the data is all linked together. You can't do that if the data is not linked together. You'd have to like import that into some giant data lake and like build a giant database that had all the data in the right way so you could ask that question. So schema.org is one technology that like Google and Bing rely on to encourage people who are building websites to structure their data in a way that is parsable. Okay, so I've been basically over linked data at this point. As long as you just keep thinking of linked data as like the internet's a database that works, then you pretty much get what linked data is about. The next thing that I'm going to talk about is just a brief summary of these decentralized identifiers. They are a form of linked data. So you can see this one has a context here. You can see some private keys up here. And you can see, oh yeah, sorry, thank you. All right, so public-private key pair, identifier derived from public key, a description of a public key, these things like authentication, assertion method, some key agreement stuff. You don't need to worry about that. This identifier here is expressing some cryptographic capabilities using linked data. And so now what the whole point of this talk is to tell you about what are linked data signatures. So we've covered what linked data is. Who here has any experience with cryptography, like building signatures, using signatures, signing things? All right, excellent, good. So this is, I'm not gonna have to do like signatures one-on-one. We've got this public key here. That's what we're gonna be using to verify signatures against. And the private key is gonna be used to create the signature. And this, I haven't really tested this with this level of zoom. All right, okay, you could sort of see this, right? Oh, you can see it better than I can, and I've got stuff in my way. Okay, so this is the credential. It's about like this concept of like a university degree. And it's like applying to this identifier here. And it's saying this identifier has a bachelor's degree. And you know, it's coming from this issuer. And so when you like log into Facebook or your auth tokens are, you know, floating around in your browser, those are all just signed pieces of data that come from an issuer that websites trust. So what this is here is it's a way of saying that these things called decentralized identifiers that express themselves using linked data. And they are going to have some keys associated with them, which I just showed you. And they're going to use those keys to sign some claims about some subjects. Like the claim about this subject is that they have a bachelor's degree. And that's going to be verifiable because all the data is linked. So you're going to be able to go back to the guy, the identifier, you're going to be able to get the keys from the identifier, you're going to be able to check the signature with the keys, and you're going to be able to say, this identifier said this thing about this guy, and I can prove it. The credential is verifiable. The terminology W3C chooses for this stuff is not super helpful because any kind of signature is sort of verifiable. But the point here is that this is a way of signing linked data, right? So this proof piece down here is the signature on top of this linked data. So there's a bunch of different signature suites, like ways of creating signatures on linked data. So one of them that we created recently was with GPG. So open pgp.js, it's an awesome JavaScript library. The guys behind Proton Mail somehow involved in it. It's great. You can run GPG, PGP signatures in the browser. You can do really awesome stuff with it. This linked data signature suite uses GPG to sign these JSON linked data objects. This one uses regular vanilla JWS. This is probably a thing you guys are much more familiar with. This is the JavaScript object signing and encryption standard, JOSE. JWS is the signature portion of that. And there's, you know, some cryptography specific stuff like these different curves and RSA, you know, like different ways of expressing keys or performing signature algorithms. Like ES256K is the way to use a Bitcoin or Ethereum curve and create a JWS signature, the ones that you guys are probably most familiar with. So at this point, like I've just vomited a bunch of standards stuff on you. I've shared some information around how linked data is, you know, related, what we use it for. And the final thing that I'm just going to kind of comment on is regarding this concept of like XML and the pain that comes from dealing with it. So what linked data is it's pointers to other data, right? Like this definition that we're looking at right here has like a number of URLs. So when you sign linked data, you're signing like a chunk of a graph. And so there's questions about like what do you need to do to that graph to get it into a representation that's signable? And I'm going to save you guys like a ton of time digging through, like thinking about how to sign graphs. There's algorithms that you apply to a graph that will canonize it and that will make a string representation of that graph that will be the same for like XML-based linked data formats and JSON linked data formats. So what happens when you create one of these linked data credentials, or signed linked data documents, is you actually take this graph data structure that is represented by, yeah, you go.
So are you saying the graph is like this abstract data structure, or are you saying the string serialized version is this JSON-LD or XML-LD?
So this is a representation of linked data in JSON.
Right.
There is a representation of this in XML. But those are just representations of.
Right. Okay. So you can serialize across back and forth.
Right.
The XML is just a lot longer.
What's that?
The XML is just a lot longer.
Yeah, it's uglier, it's longer, and it's there's probably like miles and miles and miles of XML, like legacy information saved somewhere. And if you wanted to like start translating that or signing it or working with it, you would want to take advantage of the fact that it was linked data as a way of doing that. So what happens is this JSON object gets converted to endpods, which is this representation. It's like a line delimited thing. That string file gets hashed using a hashing algorithm like SHA-256. And that becomes the document verified data. And then these pieces over here, like type and created and proof purpose, verification method, well, not verification method, but these objects here, they get also canonized and converted to a string format and hashed, and they get concatenated with the document hash. And that is the thing that gets signed. And so what that does is it it prevents like replay attacks because you actually have a timestamp that's included in here. It's sort of similar to the concept of like the proof or proof option sort of chunk of that signature is sort of similar to the way that headers work in Jose. So if you've seen the protected header section of a JSON web token, it's kind of like doing the same kind of thing. And once you combine those two things together, you can sign this object that represents this concept of linked data in a way that's preserving the fact that it's linked data, and it's also providing integrity protection across it. It's providing sort of guarantee about the canonization approach that you've taken to it. And these JSON linked data signatures that are used to create verifiable credentials can, using the power of JSON linked data, they can just define anything that humans can define with semantic meaning. You can define in a way that's machine parsable. So if you were creating a weird credential for some kind of agriculture business and you wanted to express specific weather conditions that had to do with avocado farming, you could create a credential that said that the farmer certified that this amount of rain happened and this were the crop, observations of the crop at these times with whatever data structures you want, and you can express that information in a way that is semantically disambiguated and that is authenticated and that's all linked together. And what that lets you do is it lets you combine these different data sources like IoT, like agriculture, fintech, because each of them have their own ontology, which is like representing the information in them. And a lot of those ontologies use OWL or RDF or semantic web technologies to express the relationships between these things. So once you create credentials that are compatible with those, you can bridge all of those different domains together in a way where you can sort of have some kind of trust about how, when you're importing some sensor data from some IoT device, it's coming in a way that's structured that you can verify, and that you can also relate those concepts to other concepts that you might be parsing. So I think that's probably enough rambling about JSON linked data. Are there any questions?
What is it that you keep referring to as Jose?
Jose, yes. So Jose is the JavaScript object signing and encryption library. And so this is like the thing, when you see JWTs, which is like that's an object that is base64 URL encoded JSON object, a header, and a payload. And then the final piece of it is the signature piece. And that's base64 URL encoded signature. And that signature piece is like roughly equivalent to this piece right here. Actually, this is a JWS. But this is a special kind of detached JWS. You can see it has two periods here. And what that means is that the payload is not in the JWS. The payload is that thing that I just explained. It's the document hash and the options hash. That is the payload. And you don't need to include it here because you're looking at it. That's what this is. So the algorithm that generates this credential, when you go to verify this, it's going to reconstruct that, what's called like create verify data. And then it's going to insert that into this space between these two dots, and it's going to run the JWS verify algorithm on it, and it's going to get like a yes or no. And that's Jose, that's the Jose signature standard for that. But if you wanted to do the same thing for GPG, every other part of what I just said is the same, except for the part where you decide that you're going to sign with GPG. And in that case, you're just using GPG detached signatures instead of Jose. And you're going to get some output, and you're going to encode that output, and it's going to be like a signature value, and it's going to be somewhere in here. I don't think I have a nice example of it here, but it looks the same as the other one, basically. It's just signed with a different technology. And so I think why am I giving this talk at the Node meetup? Both of these are built with JavaScript. They run as command line tools, or the NPM library Jose actually uses Node 12 and supports all of the Bitcoin and Ethereum curve crypto out of the box, because that's actually available in Node 12, not in other versions. So if you are trying to sign semantic web information, you can use Node to do it. And then you can trust the data that's flowing around, because you'll know that no one has changed any of it. Cool.
So is there an infrastructure to get the public keys or sign?
Yeah. So basically the way that this stuff works is there's this thing called the Universal Resolver, which is, we're also members of the Decentralized Identity Foundation, and I work with Microsoft on a bunch of related projects to all of this. But this Universal Resolver thing here, I'm gonna have to do that a bunch. So this is a sovereign decentralized identifier. So who here knows what Hyperledger is? Hyperledger Indy? Okay, wow, look, you guys, okay, so you maybe know the Sovereign Foundation. This is their identifier. There's all these different identifiers in here. Like BTCR, that's on top of Bitcoin. This is Verus1, this is Ether, that's built on top of Ethereum. NACL, also built by the Uport team. YOLOCOM, European company built on top of Ethereum. IPID, related to IPFS. This is their decentralized identifier. This is Seaborg. Element, this is our decentralized identifier. I'm hopeful that this is actually going to work right now. We've broken the universal resolver in context processing like a number of times recently, so I would not be surprised if this doesn't work. Oh, it worked. So you can see here, like, we've got a bunch of different encryption keys. So what this technology here is showing you is that regardless of which blockchain you want to work on, if you express your decentralized identifier using linked data, they can all be connected. Like, we're not going to be stuck in a world with only IBM or IBM products powering all of identity, because anyone can join this ecosystem and define something that's semantically equivalent to whatever IBM is providing and compete with them. But that only works if it's all linked data, because the second that you delete that context, you create an opportunity for IBM to create value that's siloed, that's not connected to the rest of the ecosystem. And they might do really great things in that siloed world, like create a lot of value, attract a lot of attention, but you will not be able to get into that world without having some semantic hack for linking that data together. And what this universal resolver shows you is, like, right now, all of these guys actually are linked data compliant. And so there's not just like one identity provider out there. It's Microsoft, IBM, small companies like Transmute, Ethereum companies, Consensus, you know, all these different companies building different identity infrastructure, and it's all interoperable, compatible because of this thing called JSON-LD data.
Okay, I'm going to try and give a summary of what we just learned. And I want you to say no match or stupid or close, because I'm not going to get it right totally. But essentially, it seems that the technologies that you're showing us are analogous to HTML and URLs, but sort of with an expansive internet now being able to look and identify and reference many different types of things. And those things could be you, or Steele as an individual, or could be an avocado, or even Steele. And since these things are real in the real world now, you can verify that they actually are what they claim to be. That's where all this encryption and these protocols and formats come into play. But what we're essentially seeing are the makings of expanding the internet to refer to everything in the world.
Yeah, that's it, basically. We want to secure all of this linked data before we try and do a ton of machine learning on data that's really easy to corrupt. Right?
More questions for it? How is this scalable?
Yeah, that's a good question. So what do you mean by scalable?
When you have avocados, you have the peel of the avocado, you have the seed of the avocado.
So it's like with anything, like you can choose to just stop defining it at any point, or you could just never stop and keep going forever, all the way down to like the atoms in the avocado, like linking them. I think there's a point at which you've kind of like hit the point of diminishing returns from a business perspective. Like, you've captured the core features of IoT, agriculture, and finance to support agricultural futures use cases for like 90% of like what happens today. Do you need to keep defining linked data attributes and exploring those ontologies further and adding, you know, additional definition? Like, no, you could, but at the point at which, you know, the futures trader can tell that avocado prices are going to suck because it rained a lot, and or because the IoT devices all failed for some other unrelated software or firmware update reason, and like that is all expressible in a way that's like queryable and meaningful to that person, and you can get some kind of value out of it, you've done enough at that point, potentially.
No, and I totally understand that. Just outside, for instance, that we have no that's something.
Yeah, so I mean, that's a really good point. Like, you can't, there's no free lunch here, right? If you want an ontology for agriculture, you either got to go find one that exists or build it yourself, right? And there won't be any semantic linking into some system that isn't annotated for semantic linking. So there are lots of people who spend their whole lives just creating ontologies and making these data structures such that you can link, you know, you can know what kind of loan a loan is, and you can know the relationship between the properties in a loan, you know, if you're a fintech person. And there's a lot of complexity that goes into defining that ontology. And you need that structure to be able to explore that data with semantic value.
So schema.org has an example of the person and all its properties. How does this get amended over time?
Yeah. So this it gets kind of complicated. But basically, these context things that I've just discussed, they create these namespaces, and
what I'm getting at is there's a attribute of spouse, but none for ex-girlfriends. And I think, how can you track someone everyone do?
So what you do is basically, for schema.org, there's a file that looks like this. You open a pull request. Command plus, yeah, sorry. So you pretty much need to open a pull request and edit a JSON file to define something like cryptography key, sec key, and then sec points to this thing, which defines the security vocabulary. And when I click this link, I should be able to get to a definition for what a cryptography key is. And sure enough, like I can read about all of these different pieces here. So in order to fix this stuff, you need to be capable of opening a pull request to change a JSON object and potentially to add some documentation to an HTML page. And once you do that, the context will be updated. The context, whether or not that should be allowed is sort of more for the maintainers of that namespace. Like, what if you go and try to add a bunch of lies, right? Someone has to maintain the integrity of this system, and you would want to version these different things. So like the did spec for decentralized identifiers has versions, and you can be V11 compatible, or you can be V12 compatible or V13 compatible. And when those you get to those other versions, you're going to get different properties that are available that you can express, your things, aspects of your identity in a semantically disambiguated format. So each time you publish a new version of a context, you're basically updating this entire universe of terms and vocabulary that are defined.
So it's interesting that this is a number of different emerging standards that are emerging because they're sort of evolving to suit future use cases. What is the cutting edge of these in actual use? If there is any.
So, I think there's a couple different ways to answer that question. So, at Transmute, we work with the US government to try and apply this technology to the raw materials imports use case. So, like specifically, Department of Homeland Security, Silicon Valley Innovation Program, we work with Customs and Border Protection, and we're trying to develop these things called, steel mill certificates, which basically get created anytime you create a steel product. And it's a self-attested claim about a steel product. Like, I'm making steel for Matt. Matt wants to buy some rebar from me. I'm going to make some rebar. I'm going to get a piece of paper out. I'm going to sign. I made rebar. It had these chemical properties. I'm in Mexico. I'm going to ship it to you. And when that rebar hits the border and someone's looking at a pile of steel going like, what kind of steel is this? Like, does this have the right amount of chromium in it? Or is it the chromium too high? And like, how am I going to tariff this properly? Like, what is this, right? So I think the cutting edge of the credential technology is basically product attributes, right? Because their product attributes have so much complexity that can exist. Like, you can go to any pharmacy, you can pick up a bottle, it's going to have a QR code on it. A lot of the time, it'll say right next to the QR code, scan this to see test results. But like, when you scan that and you see the test results, is it like signed by like an authority? Is there cryptography there? Is someone just promising that they tested it? Does this baby formula really not have metal shavings in it? And if it does, and I find that, how am I going to go back and figure out who lied, right? Like that's a big problem. So product attributes are like part of the cutting edge. But in terms of like blockchain identifiers, I would say like a lot of the addresses that are involved in like various different crimes, like each of those have identities, and there's like a lot of graph linking that goes into like tainted Bitcoins. Like not all Bitcoins are worth the same amount of money. It's kind of confusing, but like a Bitcoin that's come from a compromised like dark market, like the US Marshals just sold off like a ton of Bitcoin from like a bunch of raids. The problem is that if you bought that Bitcoin and then you go use that Bitcoin with any trading firm that is like trying to be at least somewhat compliant, it's going to get triggered every single time you move a coin that's related to that, because it's all going to get traced back to this one time when it was in a known allocation criminal activity. So it's going to hit like a flag every time you move that Bitcoin. And that comes from understanding the relationship between these addresses and the previous history of those transactions. So like that's an example where like this structure around like linking between like criminal, Alphabet had this Bitcoin at one point, then US Marshals sold it to this hedge fund who then, you know, did something else over here. And like, why is my transaction not going through? It's because it's flagged, because it will always be flagged because of that.
So what triggers the flag itself? Like, how do you know who from the what?
Yeah, so like you have to, at the point at which there's some software system that's parsing some data that's potentially linked, it's up to that software system to decide how much of that graph they want to crawl to make that decision. So you could decide, I'm going to go look at like 3 transactions back on this Bitcoin. I don't care about its entire. Oh yeah, so all that you're going to get are these identifiers, right? The mapping between pseudonymous identifiers and real life people, like you have to maintain that database somewhere else, which they do.
Somewhere else.
Yeah, somewhere else.
All right, I got
Who's
it.
the thing?
People who want to maintain identifiers and mappings between identifiers and other sets of identifiers or things. Like, for example, I have like a million different decentralized identifiers because I work in this space, but a lot of them are published on GitHub. So you could crawl GitHub for identifiers, and you can map them to like commits, users. You could start to actually, when you see this BTCR identifier, you could know it was actually probably me, because you just have found GitHub and you've crawled that and you've built that mapping. And then you can instantly resolve anytime you see that identifier doing something, you could just substitute in my name in a way that would be like linked data compliant. And you know that like that's not just this anonymous person, that's this person that I have identified. And that's another use of this technology. So it's like, it's a tool. With great power comes great responsibility. And it's basically your fault if you create correlatable identifiers and leak them on the public internet.
But you cannot trust only unless it's tracked, right? Well, and that fact, you cannot trust unless you know that the verifying source is true.
You can so you would verify the cryptography layer of all this, but
So go back to this thing, right?
Yeah.
So if I tell you, maybe Steele is down like XYZ,
yeah,
you will trust it because I have an encryption key.
you trust that you haven't lost that encryption key. We trust that. Yeah, well, I mean, you can't lie about what you've committed to, but it could have been someone other than you that signed with that key,
So
right?
how can you verify that? That's
So like that gets into authentication and like other layers of cryptography, but like, you know, obviously there's certain things where you have to show up in person to do them.
Yeah.
And when you combine those, so it's like in the NIST guidelines, it's like identity assurance level. So there's identity assurance level 2. That's kind of like what you get when you do like remote authentication. You log in with the username and password. It's kind of like what identity assurance level 2 is. That's not going to work if you're like going into a top secret room and you're about to handle a bunch of like classified information. You can't remote authenticate and get into that. They're gonna scan your PIB card. They're gonna check to make sure everything's good. There's gonna be like a Marine with a gun. He's gonna look at you like.
No, but it's just the fact that to be able to trust the source,
Yeah.
you have to verify the source, don't you?
You have to trust the infrastructure associated with the claims. So like in the case of like Bitcoin or Ethereum transactions, when you see that someone has transferred Bitcoin from one place to another, and you know that, you know, you had previously confirmed, I confirmed that you're in control of the private key, right? But then I see that transaction happen later. So like, I know that it's this, whoever is moving this is a person in control of the private key. I believe it's you if I think you have good operational security. I don't believe it's you if I think you have terrible operational security and you tweet your private keys. I'm definitely not going to think it's you.
Yeah, for sure.
Yeah.
Okay. Thank you. I appreciate that.
So this may not be happening, but how is like an Equifax or a credit bureau, which has an identifier for me,
Yeah.
and then is trying to associate it with all of these events in the world, like
Yeah.
if I ever sold, bogus Bitcoin or whatever, how are they going to associate that transaction back with some internal identity that they keep of me?
So, I mean, I don't know exactly how
But they would use something like what you built here.
they have a big database. They have a bunch of identifiers for different pieces of information. They ingest large amounts of information from a number of different sources. So one of the things that credit bureaus do, which is super valuable, is they actually consume stolen data sets from compromises. So they will when Dropbox got hacked a while ago, 2012 or something like that. And I don't know if you guys remember who StoneTier was, but StoneTier was Hillary Clinton's email guy during the 2016 election, who tried to delete all of her emails with BleachBit, and then got found out by Reddit. And he happened to use the same handle that he used his whole life, and it happened to be one of those emails that was breached. And so when you go to have I been pwned and you type in his email, you'll figure out he was breached in this hack. These credit bureaus are ingesting all of that information, and they're trying to build a picture profile of unique individuals. Ad tech companies are basically doing the same kind of thing, right? So you just ingesting as much information as you can, and you want to be able to build links that you have confidence in, and you want to maintain all of that data. You want to keep it up to date because it changes. You might have terrible credit today, you might have good credit tomorrow. Some of these facts are true forever, and some of them, they need to be updated, and those guys, they have to maintain all of that. What?
So centralized.
Well, the credit bureaus, yeah, they're totally centralized. And for a lot of these cases, centralization is not bad. The interoperability that all of these different identity methods have gotten comes from agreeing to a common language, a vocabulary. Centralization is what allows us to say, this is what we support. If you don't do this, I can't promise I'm going to be able to work with you or talk to you or respect you or whatever, right? And centralizing that in one place allows for interoperability, and it's great. Putting a bunch of personal information, in some credit reporting database also helps. It helps easily run queries. It just is a massive honeypot, and attracts attackers. And they only need to get in once to get everything. Yeah. But I mean, one other use of this technology is to give users control over all of that information and allow them to disclose these pieces of information out. So it's probably a whole nother talk on just that, but there's these things called encrypted data vaults or personal data stores or secure data hubs, and it just goes on forever. But the idea behind them is to give users control over their personal information and use the same decentralized identity and cryptography to give the people the control authority over when that information will be used and for what purposes, and with the ability to revoke. I'm not going to let you use this information anymore. I'm going to share my medical records with researchers, but I'm not going to share them over here with this insurance company that's suing me or whatever, right? And so, yeah, all of this once you have the linked data, once you have the data structures and you have the cryptography, you can start to decide what you're going to give out and what you're not going to give out. Yeah. I mean, your data by itself isn't really worth very much, but when you add up all of the different data and you start to be able to do this deeper demographic mapping, it starts to be worth a ton of money. Yeah, and as long as you aren't actually you're not consenting to that information, you're not really aware of all that data that's stored about you, you'll never really be in a position to benefit from any of that ever until you can control it.
It's the biggest commodity out there. Yeah.
So
But again, as long as you don't correlate the data to a person.
Yeah. So you want to be
It's feasible, like, to just use it.
Yeah, so you want to be really careful with these cryptography products. You don't want to store PII in them. You don't want to like I could go on the Ethereum ledger today and I can write a transaction that's my name on it. It'll be there forever. Everyone's going to have to store that forever, and there's things that you could do in the identity space that would be like thousands of times worse than that you really shouldn't do. You should treat anything like that's ever going to be in an immutable system as that it's going to be there forever, and don't encrypt data and then put it there, because encryption has a shelf life. It's like not very long in a lot of cases.
That's one of the most,
Yeah.
it's just great.
Yeah.
That's awesome.